Okay, and we're going to talk about centripetal acceleration today. Woohoo! So, what is centripetal acceleration? Well, centripetal acceleration has to do with circular motion. Circular motion. Now, this means you're traveling in, get this, a circle. So let's say that you are running around in a circle like that. Now, at each part of your motion, you're going to be traveling a different way. So this is your velocity at this point, and this is your velocity at this point. You would agree, hopefully, you should agree, that those velocities are different because they have different directions, right? Velocity is direction dependent. So, since there is a change in velocity, right? Change in velocity, that means that there is acceleration. Now, the acceleration is centripetal acceleration. Okay, centripetal acceleration always points towards the center of a circle. Always to center. Now, you're going to be accelerating different directions at different points in the circle. So when you're at this point, you're going to be accelerating that way. When you're here, you're accelerating this way. It's always pointing towards the middle. That's the way you're accelerating, and that will give you the curve of the circle. So as you're traveling this way, you're going to be accelerating directly to your left, which will cause you to turn and go this way. And then you'll be accelerating to your left again. And that's how centripetal acceleration works. Okay, so I know you're worried, but don't worry, it's got a formula. So A, which is your centripetal acceleration, sometimes you do AC to make sure that centripetal acceleration is equal to v squared over r. Okay, so this is your centripetal acceleration, only for centripetal acceleration, not for like any acceleration. This is for your velocity. Velocity is going to be in meters per second, of course. You're going to square it, so so the direction doesn't really matter for this. And then r is for the radius, which is in meters. Now you'll have a meter squared over second squared divided by meters, and that gives you a meters per second squared. So if you're worried, the units do line up with this because they have to. So hopefully that makes it a little easier for you. All right. So let's talk about centripetal force. All right, to talk about this, we're going to give you a formula. Maybe you've seen this formula before. F is equal to ma. So if we take this formula and replace the a, because a for centripetal is going to equal v squared over r, we can just stick in mv squared over r, and this is your centripetal force formula. Ta-da! Now, we've talked about a lot of forces here, but something you should know is centripetal force is not a real force. Okay, let me tell you what I mean by real, because I'll put it in quotes, because it's not like an official term. This is a Mr. Keeney term. So we've talked about real forces before. What are some real forces? And here's where we would go through a bunch of them in class. So if you yell really loudly, maybe I'll hear you in the past through the YouTube. So one of them I heard was gravity. There is such thing as a force of gravity. There's a force of friction. There is a force of tension. And then there's just your everyday push or pull, right? Oh, and there's a normal force too. I think that's all I can think of offhand. But anyways, so these are all forces. These are all things that you've seen so far in your physics career. Okay? Now, centripetal force is not a real force. It is other forces acting as centripetal force. Alright, so centripetal force is not going to be this new thing. What you're going to have is you're going to have one of your regular guys here acting as a centripetal force. Okay, so let's say you had your favorite yo-yo and you were spinning it in a circle like that. Well, the force of tension is going to be the centripetal force for this one, because the force of tension is what is causing the circular motion. Right? So centripetal force isn't a real force, but your tension force is acting as your centripetal force. Now, this could also be gravity, it could also be friction, it could be whatever. It just depends on the situation. All right, we're going to look at some a little later. Now, there's another word here. It's centrifugal force, right? Centrifugal force, whatever you want to say, I don't care. But this is not the same thing. So let's say, I put a question mark here just because this is a big misconception. This is not the same as centripetal force. Alright, or however it's spelled. So these are not equal to each other. We talked about what centripetal force is. That's the one that pulls you towards the center. Centrifugal force is a force out from object's point of view. Point of view. Okay, so let's give you an example. You're driving in the car, well, you're riding in the car, your friend's driving, right? So here's the windshield. This is as seen from above. There's the roof. Here's the back shield. All right, so here's your friend. They're driving the steering wheel, if you can call it that. And here's you. Now, they're really bad, and they're getting off at this exit ramp here, right? But they're too cool for slowing down for that. So what's going to happen is you are going to feel like you are going to get pushed this way. Now, you're actually not getting pushed that way at all. What's really happening is the centripetal force, Fc, is going to be pointing to the right because that's towards the center of that circle. But you are accelerating to the right, but your frame of reference, right, your point of view, whatever, is not accelerating, right? So your frame of reference is accelerating, so this makes it a non-inertial frame of reference. I don't know if you remember, we talked about this a long time ago, which means you'll have an extra force there, and this is the centrifugal force. So this is an extra force for non-inertial frame of reference. Alright, so it's not, that one isn't really happening at all, ever. It's just you feel like it within the frame of reference. That's it. Okay? Hopefully that helps. We're not going to really do anything with centrifugal force, but some people like to mix these words up, and we want to make sure you're not like one of those people. Okay. So let's do some practice. You spin a ball, a 3 kilogram ball in a string. It's moving at 1.5 meters per second on that much string. What is the force of tension? Okay, so here's the ball. It's 3 kilograms. Right, horizontally, you don't have to worry about gravity, none of that stuff. 2 meters, and it's traveling at 1.5 meters per second. Well, let's draw forces. The force of tension is right here, and the force of tension is equal to your force of centripetal, because that is the centripetal force in this particular thing. Now we have a formula for force centripetal. Force of centripetal is mass times acceleration. Acceleration is v squared over r. So that's going to equal your force. We'll say tension, whatever. All right, we know the mass. The mass is 3. We know the velocity. The velocity is 1.5. It's going to be squared. We're going to divide by 2. All right, so we are going to have 1.5 squared divided by 2 times 3, which is the same thing as cubed, whatever. So your force of tension is going to equal about 3 point, I'll round it up to 4 newtons. Ta-da! So that's it. Let's do another one. You sit in a merry-go-round for 3 meters from the axis and make a lap every 2 seconds. What is the minimum coefficient of friction? Alright, so let's draw a picture. Here's you sitting down. Let's see, we'll draw your legs folded and whatever. Okay, so 2 seconds go by and you're back, and you're 3 meters away. Alright, so far so good. You can pause the video, see if you can do it. The first thing you have to do is figure out your velocity, right? Well, let's kind of set this up here. So your force of friction is going to be right there. That's going to be your centripetal force. Your normal force and your gravity going in and out of the screen, they cancel out. I'm not going to worry. I'm not going to draw them because it's not worth it. So your force of friction is going to equal your centripetal force, which is mv squared over r. Are we okay if I just don't write everything down? So we know our force of friction is going to be mu times your force normal, which is equal to the same thing. Force of normal is going to be m times g, so we're going to have mu mg is going to equal mv squared over r. Hey, would you look at that? The m's cancel out. Ta-da! Alright, so we still have to figure out g. I still didn't do that yet. Alright, so velocity, in case you don't remember, is distance divided by time. Now, I have a time. I've got this 2 seconds. What does it stand for? It stands for 1 lap. So, how far do you go in 1 lap? Well, you're going to be going 2 times pi times the radius of 3, because that's the circumference, right? So, we're going to have 3 pi, because the 2's take each other out, and we're going to get 9.42. 9.42 meters per second. So that's how fast you're going. So mu is going to equal v squared over grr. Alright? I just moved the g over because why not? So v, we know what that is, 9.42. We're going to square that, divided by 9.8 times 3. So multiplying these puppies together, woof, woof. I got about 3.0. 3.0. And no unit because it's a coefficient of friction. So you better be very sticky because you're going around really quick. But hey, whatever, man. Make sure you divide those properly, I suppose. Anyway, so that's that. Did we have another one? I don't remember. Well, I guess we'll find out.